Okay, so I wanted to record this video to give a little bit more explanation and kind of help maybe some of you guys who are struggling with stoichiometry. So I'm going to talk a little bit about what stoichiometry is, just kind of refresh, and then solve a couple problems using a balanced chemical reaction. I do want you to note that this will not be a video that is on limiting excess reactants. That's kind of an add-on to stoichiometry. So right now, what we're just focusing on is stoichiometry. We're just that one basic idea. So let's start with a balanced chemical reaction or with a chemical reaction. So let's, I'm trying to find the one that I wanted to use. Let's just use this one. Let's say that we have methane CH4 plus 2O2 and we are producing carbon dioxide and water. Now this reaction is already balanced, but if I were to talk about like steps in order to solve stoichiometry problem, is one of the first steps is you want to double check reaction is balanced. If your reaction is not balanced, you will get the wrong answer because you need to have your correct coefficients in front of the numbers. Now, when we look at a chemical reaction is a recipe, as I've mentioned before. And what this tells me is that 1 mole of methane, so our 1 mole of methane will react with 2 moles of oxygen, and we will be able to produce 1 mole of carbon dioxide and 2 moles of water. So let's start off with something really kind of basic and simple to think about. If I wanted to double the amount of water that was produced, hopefully it makes sense that I would need to double the amount of my reactants. So let's say that I wanted to produce 4 moles of water. Now, I know that in order to produce water, I need to react methane and oxygen. Now let's say how much methane would I need to react with it? Well, I need to use a mole to mole ratio. This mole to mole ratio, this invisible one is right there. This tells me how much of my methane is need to produce a certain amount of water. So I'm going to have my 2 moles, this comes from the 2 in front, of water, and my 1 mole of methane. So what this tells me is that I would need to have 2 moles of methane in order to produce my 4 moles of water. So this right here that I used, I often will call this a mole to mole ratio. And this comes from a balanced chemical reaction. So you can see that I plugged in that balanced chemical reaction. Notice that on the bottom is I'm matching up the units and the substance. So I have moles of water, I have moles of water. Those need to cancel out. And then on top, I have the units that I want. I was looking for moles of methane. So I put my 1 mole of methane on top. And so I will need 2 moles of methane in order to react with in order to produce, 4 moles of water. So if I were to think about oxygen, I could do the same thing. So if I have 4 moles of water and I want to know how much oxygen is required for that, I'm going to do the same thing. But now I'm going to look at oxygen. So now we have 2 moles of water and 2 moles of oxygen. So again, moles of water here. So my moles of water need to go down here to cancel out. And then my moles of oxygen are going to come up top. It's a nice, easy one to solve because this just ends up being 4 moles of oxygen. So if I wanted to double the amount of water produced, if we look at these, what this is telling me is that I would need to double both of my reactants. And if we think back to a recipe, if you had a recipe for cookies and you wanted to double the amount of cookies you make because you're giving them out to a bunch of people, you would need to double all your ingredients. And that's all I'm saying right here, is that when I want to change the amount of how much is being produced, I need to make sure that I change my ingredients as well by the same factor. So we can use mole-to-mole ratios. So we use a mole-to-mole ratio that comes from our balanced chemical equation. And notice that this is getting us from one substance to another. So we're not going within a substance. It's like we're going from moles of water to grams of water. We're going from one substance to another. So we're kind of switching tracks here. So let's go ahead and look at a problem that is a little bit more difficult because we'll be adding mass in here. So let's stick with the same equation that we had before. So we have CH4 plus 2O2, and we are going to produce carbon dioxide and 2 moles of water. Now I want us to think about, what if I said I wanted to react 10 grams of methane, and I wanted to know how much carbon dioxide would I be able to produce? Well, when we think about this, we can think about kind of a roadmap, and I've shown you guys this during class, and it's a helpful roadmap, I think. So if you're starting with a substance, let's call it A in grams. The first thing you need to do is you need to convert A into moles of A. Because remember, from our previous problem, the only way to get from one substance to another is to go to moles. So I'm going to need to convert A moles. So I'm going to need to convert from there to there. Once I get to my moles, I will be able to convert it to my other substance in moles. So I'll be able to convert this into B of moles. But if I want to convert B into grams, I need to make sure that I then convert that into grams, because that's what the answer is asking for. So I want to B into grams. So these are my this is my roadmap. I want to go from grams of A to moles of A to moles of B to grams of B. So now how do we do each one of these steps? We need to remember what we've talked about. So whenever we want to convert between grams of a substance and moles of that same substance, what we need to do is we need to use our molar mass. So I'm going to use my molar mass of methane, or of A, excuse me. Let me go ahead and put A since we're talking about A here. So it's going to be the molar mass of A. So we need to figure out our molar mass, and that's going to allow us to convert between grams and moles. Then what we need to do is we need to convert between moles of A and moles of B. And when we do this, we're going to use a mole-to-mole ratio. And this is the exact same mole-to-mole ratio that we used in the previous problem. So it just comes from our balanced chemical reaction. And then here we are at a mole to grams conversion, which is really just the opposite of this. So we're still going to use molar mass, but now we're going to use the molar mass of the other substance. So we're going to call this molar mass of B. So don't forget that when you're trying to find your molar mass, this comes from your periodic table. This comes from your balanced reaction. And again, this comes from your periodic table. So let's go ahead and solve this using our roadmap. And if I were to plug in my values that I have, so what I have is I'm going to start with my 10 grams of methane. I want to convert this into moles of methane. Then I want to convert this into moles of carbon dioxide. And once I get to moles of carbon dioxide, I want to convert this into grams of carbon dioxide. So notice that I kind of just plugged that in. I'm going from one substance to another. So now I want to plug in those variables. So let's go ahead and set up this problem with some information. We are going to need a periodic table to calculate some molar masses. So let's go ahead and solve. So we have 10 grams of methane. So you always want to start with that. So start with what's given. We have 10 grams of methane. Now, my first thing I need to plug in is my molar mass. So I need to calculate my molar mass of methane. 4 plus 12.01. And I get 16.05 grams of methane. And that is 1 mole. Because remember, whoops, I wrote that wrong. This should be 4. This should be 4. Because remember, our molar mass has units of grams over moles. This can be switched up and down. This can be grams over moles. We can switch whole things and say moles over grams, which is what we did. So this is always going to be a 1 on top of here. So notice that my grams are on the bottom because those need to cancel out. And my molar mass is always compared to 1 mole. Then what I'm going to do is I'm going to do a mole to mole ratio. So I need to look at my balanced chemical reaction. See, remember, go back to your balanced chemical reaction. And I want to go between the substance that I was given and the substance that I'm looking for. So because there is no number there, that means that it is a 1 mole methane to 1 mole carbon dioxide. And then last but not least, the last thing I need to do is I need to convert my moles of carbon dioxide into mass. I need to convert that into grams. So I'm going to use my molar mass of carbon dioxide. So again, going back to my periodic table, we're going to do oxygen, let's say 16 times 2 plus 12.01. Let's say it is 44.01 grams of carbon dioxide and 1 mole. Notice that I did put the 1 mole on the bottom because, again, these units need to cancel out. You can't flip this. So my 44.0 grams is on top. So I end up getting the units that I'm looking for. I'm looking for grams of carbon dioxide. So if I were to solve this, I'm going to multiply 10 times 44.01. And I'm going to divide it by 16.05. And I get 27.4 grams of carbon dioxide. So that is how much carbon dioxide would be produced. So notice the different steps. If we go back to this one, we're just going from moles of a substance to moles of another substance. So there's only 1 step. But over here, I did need to convert first my grams into moles. And so I just put that all together. If you are struggling, I would write this kind of thing out on the top of your paper and start labeling. What are you given? What are you starting with? And just start plugging things into this roadmap, because these are the steps. And this is the roadmap that you can use to solve any of these stoichiometry problems. If we think about this roadmap and we kind of go back to our example on the first one, we started off with 4 moles of water. And I wanted to know how many moles of methane. So notice I'm just doing 1 step. I'm just going from moles of A, which was water, to moles of B, which was methane. And why do I keep putting 3? So use B4. So I'm just going from moles of one thing to moles of another. So it's just 1 step. It's just a mole to mole ratio that I need to plug in. So it's very helpful to use this roadmap if you are struggling. Once you use this roadmap a couple times, it does start to become second nature, and it does start to become a lot easier. So I hope this video helps. If you guys have questions, please feel free to reach out with questions.